Welcome everyone to our today's webinar. My name is Orest. I'm a solutions engineer at StarWind. Now, today we have quite an interesting topic, which is how to implement disaster recovery properly in SMB or SME IT infrastructure. Now, it will be quite a complex webinar. There are a lot of things to talk about, really. So before we actually start, let's take a look at our today's agenda to make sure we're all on the same page. So first, we're going to briefly discuss what disaster recovery is and how it works, the main ideas behind it. We're going to also talk about the most important, or definitely not all, aspects of a proper disaster recovery implementation in SME environments. We're also going to see what are the methods or types of DR. We're also going to be focusing mainly on the virtualized environments and disaster recovery tools in them, such as Hyper-V Replica, vSphere Replication, and Veeam Backup and Replication. And traditionally, in the end, we will have a short Q&A session where if you will have any questions, I will, of course, try to answer them. So let's actually start. And first, let's gonna settle on what disaster recovery is. Now, it's quite a complex term, and it is usually included as one of the aspects of business continuity. Now, not to get involved in all the terms, definitions, etc., I'm just gonna provide a quick definition of what business continuity basically is. It's the overall, let's say, approach and the concept, basically the organization's ability to maintain and continue the work of services and delivery of products at the acceptable levels that are defined per company after a disaster has occurred. Now, basically, business continuity main goal is to prevent interruptions or to make them as small as possible to mission critical services. And of course, reestablish the function of the services as quickly as possible. Now, there are certainly various aspects that are related to business continuity, and today we are focusing on disaster recovery exactly. Now, DR, we can say that it's the subset, one of the parts of business continuity. So disaster recovery focuses on the IT, or let's say technology systems that support critical business functions. And we all know that IT plays more and more important role in the modern world. So DR is about maintaining or recovering IT infrastructure systems, and most importantly, their functionality and services they provide. So disaster recovery usually, but not exclusively, relies on a second remote, ideally location, be it in another facility, city, or cloud. And it is also usually referred to as a backup site that will hold the copy of your data, or pretty much in general terms, provide the workloads and services in case something happens to your main production site. Now, disaster types can actually be various. So here we have just several examples of them. I believe we all understand that these can be varied, starting from natural disasters and up to power outages, security breaches, equipment failure, and other caused by human factors. Now, DR in itself is a complex process. While it might seem that it sounds simple, in fact, it is complex and it requires constant attention, revision, and a good portion of planning. And basically, since I started talking about planning, let's actually move forward to some more details of how to implement DR. So usually what an organization would do when preparing the disaster recovery strategy is to perform an in-depth analysis of their systems and create a formal document that they would follow in times of crisis. Now, this document is commonly known as a disaster recovery plan. The extent of the document, its complexity, and what it covers is for the organization to decide. It can take various forms and include numerous chapters, and again, it's different for various companies. So today we'll be focusing on the most crucial aspects of a DR plan and overall approach to DR implementation in SME. Not to say this is the fully inclusive points as to what should be done in the DR plan, but certainly one of the most important. So the first on the list would be the team. So basically the DR team. I would say that DR can't be fully executed by a system administrator alone. Ideally, you would want a team consisted of several members that would cover various aspects, such as types of disasters that your organization may face, their probability, business impact, mission-critical workloads, and others. However, as it often happens, there is the single person covering everything, especially in terms of the system administration. But in that case, it is still ultimately important to have the top management of the company, CEO, CFO, CTO, aligned with system administrators in this case to have a proper understanding of how vital the IT infrastructure is for the business. It's much easier to align on the proper DR solution and as well on the budget when the top management of the company really understands how important IT infrastructure is and how many and how critically the services the business provides rely on the IT infrastructure. Now, the second logical step you would follow is to identify what you need to protect. So this would include the network equipment, the other hardware, so storage, servers, computing powers, software, cloud services, if any, and of course, your critical data. Then try to understand and analyze how your assets are used and their importance to the business. You can classify these assets into high impact, medium impact, and low impact by identifying how likely they are to disrupt business operations. Now, after this, you would like to come over to the actual assessment of risks. So that's pretty much obvious, and this is all about understanding the probabilities and types of disasters. What is worth of protecting against or taking into account, as well as how the disasters can impact the IT infrastructures and business overall. Now, definitely in some cases, the natural disasters might be of the more significance depending on the area and location. In some cases, it's not that much about of the natural disasters, but more of the, let's say, power outages or equipment failures or human-induced disasters such as security breaches. Now, once the risks are identified, you would want to come up with the clear RTO and RPO requirements for organization. So to put it simply, what is RPO and RTO? So recovery point objective is basically the maximum age of files that an organization must recover for normal operations to resume after a disaster. In other words, it's the amount of data you can tolerate to lose from the time perspective. For example, for some company, losing a day worth of data won't be a problem. For the other, losing 2 hours worth of data would be a disaster in itself. So it basically describes minimum replication frequency. And next is the recovery time objective, or simply RTO. Now, RTO refers to the amount of time and you would need to recover the services for the normal operation after a disaster. Again, in other words, it's the amount of data, it's the amount of time you would need to spin up your VMs or application after a disaster. In some cases, applications can be down for several days without severe consequences. In others, seconds can do substantial harm to the business. So basically, to put it simple, this means how fast you can recover. So both of these are extremely important, and both of these should be taken into account when preparing to the DR and also when selecting the proper methods of DR. But we'll get back to that just a bit later. Now, as to the DR methods, we'll take a look at them more deeply on the subsequent slides, but there is quite a variety. Mostly, these will depend on the type of workload NFT infrastructure you have, virtualized or not virtualized, cloud or other, and of course on your RTO and RPO requirements, as the tools are not always equal in terms of how well they can do the job and provide RPO and RTO requirements as well. Now, once you have settled up with the understanding of your critical assets, risks, and the methods you would want to implement, you would, of course, need to perform testing. It is essential to regularly test your disaster recovery plan. I mean, not just to test the DR functionality during its implementation. Of course, everyone would test mostly any solution before going for it, but it is critical to do this constantly. This includes simulating disaster scenarios and practicing recovery procedures to identify any weaknesses or gaps in your plan. It should be done, of course, on a regular basis, and the results ideally should be documented and shared with the relevant people in your organization, for example, with management. That's what I actually mean. And the final part would be training. Sure, it's extremely important to train your employees on the DR procedures so that they would know what to do in case of a disaster, where to connect to in case the infrastructure is switched. So basically, so that there was no chaos once something is down. Now, this includes educating them on using specific tools if needed, and of course, how to access the data. It must not always be the entire employees range, but for example, the persons responsible for the DR technology implementations that will further pass the instruction to heads of departments that would further guide their certain divisions in case disaster happens. And again, clear and concise documentation that outlines the steps to be taken in the event of the disaster will be always and extremely helpful here. Now, actually, one more step for the DR implementation is updating. This can come, or this will appear as part of your testing schedule, since sometimes you do changes to your infrastructure. Or as the business grows, you might have other services that become more critical, or your RPO and RTO requirements may change. So disaster recovery plans should be reviewed and updated regularly to ensure that they are still effective and relevant. So it should involve updating the plan in regard and to reflect the changes in your IT infrastructure, if any, business processes, and mainly, of course, the recovery goals. And of course, during the testing, you will update the DR when needed. So these are the main key points you would follow when preparing a decent DR plan. In fact, the DR plan would have the pretty much same concept, be it the large enterprise or SMB or SME. Okay, so now let's actually talk about how disaster recovery can be implemented. So more to the methods of disaster recovery. Now, here I'm going to talk about just 3 things, and these are the examples because there is actually a huge variety of disaster recovery methods and tools. But we'll focus on just several most popular ones, I would say. The first and most simple would be backups. Now, before we go into the rabbit hole of definitions, what DR is, what is not, and what backups are and what they're not, let's make a simple definition of a backup. So we define it as an additional, as an extra physical or virtual copy of data on another media. This can be cloud storage, this can be a NAS, this can be a dedicated backup server. And we all know about the 3-to-1 backup rule, where you want to keep different copies of data, basically several copies of data on different media, one of them off-site. So here, of course, LTO can come into play and other media types. So from this point of view, backup as an additional copy of your data is basically what DR can rely on. So basically, in other words, DR, disaster recovery, can rely on some form of backups. Now, it is, however, very important to understand that backups alone do not necessarily equal to disaster recovery. Now, main goal of backups is to keep a copy of your data safe and, of course, be able to restore it when needed. Backups are usually more about larger RPO and about being able to get back in time to previous versions of data, for example, daily increments and weekly full backups. DR, on the other hand, is not just about low RPO, but also about recovery time. Having a backup of your data and being able to restore it is one thing, but being able to recover the services that were running if the entire site with your production system fails, do it fast and make sure that they are running properly is totally different. Now, this, of course, depends on your business recovery point and recovery time objectives. What I mean is that for someone, having a dedicated backup server with attached NAS, for example, in a remote site, serving just as a backup repository is enough. If something happens to a primary production infrastructure, you still have your backup copy, for example, from a previous day, and your data is pretty much untouched. And it's fine if you will later at some point in a week or in a couple of days get another server, connect to it, and restore your VMs or your applications or whatever it can be, or just raw data from it. This also depends what is the main asset for your business, just raw data, files, or the actual services. But the question is, will that backup server be able to restore and run the applications and services or VMs that were running on the primary side? Most likely not. You would need more servers there to restore the actual backup and then continue running the production. And even in this case, that server, even in the case the server can run some mission critical services and workloads, it will take time to restore. Again, it of course depends on your recovery time objective. So in the same way, we can tell that DR does not necessarily mean backups. This is mostly visible when we are talking about virtualized environments, and we'll get to this very soon. So overall, backups are more about data safety, but not about fast recovery times. Now, the next one that is worth mentioning is disaster recovery as a service. So in this case, disaster recovery, or let's call it your data or services copy, is hosted by a third party. This can be replication and hosting of physical or virtual service by the provider to ensure failover and recovery of your services in the event of a disaster. The DRS provider, I'm just going to call it DRS, gives infrastructure that serves basically as your disaster recovery site when disaster happens. Such a service offered by the provider would typically include a software application or hardware appliance that can replicate data or virtual machines to a private or public cloud operated by that provider. Now, the basic idea here is that in the event of a real disaster, the remote vendor, which might have a globally distributed architecture, would be less likely to be impacted compared to your organization. And this allows the vendor to support the customer in worst case disaster recovery scenarios. Now, there are different types of DRS. This can be managed, assisted, or self-service. I'm just going to describe the first of them, not to go into the vast details, because this could be the full dedicated webinar on that. The managed disaster recovery as a service. In the managed DRS model, the provider usually take full responsibility for disaster recovery. Of course, this can depend on the agreement. Now, by choosing this option, of course, your organization will require to work very closely with the provider to keep all infrastructure, application, and services changes up to date, as well as also determine the RPO and RTO. You won't get anywhere from that. But if you don't have the expertise, time, or resources to manage your own disaster recovery, but you understand that it is critical for your business to have one, that would be the most optimal option. Basically, instead of trying to do this on your own, an MSP that will do this for you with a good service level agreement, they will take the responsibility for disaster recovery implementation, might be indeed the best or one of the best options. And the other type of or method of disaster recovery is virtual DR. Now, virtual disaster recovery basically refers to the use of virtualized workloads, or simply VMs, for disaster recovery planning and failover. The concept is very similar, albeit you would now need to replicate workloads to an offsite location on a VM level. The benefits of virtual DR are basically flexibility, as it is easier to choose which VMs to replicate. It simplifies implementation, as there are a variety of options to choose from, and they can be built into hypervisors. And also overall efficiency and speed when it comes not just to replication, but also to recovery of the workloads. Plus, virtualized workloads can have a small IT footprint, so replication can be done more frequently, and the failover and recovery can be done more quickly. Also, one thing to note, I believe we all understand that, but to keep everyone on the same page, when we are talking about virtualized DR, we are usually talking about asynchronous replication. That basically is replication that is done at the set intervals of time, and of course, the replica might not contain the latest data state as an original virtual machine. And now we're going to actually take a more closer look into the DR in virtualized environment, since we believe virtualization has become quite a part of our daily routines and most of the IT infrastructures. Now, again, virtualized disaster recovery is based on the before mentioned concepts of asset evaluation, RTO and RPO needs, and these are of course basics. So of course they share some common approaches and other DR methods, but this also has certain aspects to be taken into the account. Of course, first of all, you would need to understand what and which VMs should be running on DR. Perhaps some VMs are not that important and your business can easily survive without them, while others are mission critical. This heavily impacts sizing. If we're talking about the sizing, in order to be able to run your production VMs on the DR side, you of course need hardware and servers, and it is very important to size it properly. The how might be the same you are using in your primary IT, but since disasters is not something that happens constantly or predictably, of course, this might not be the best way to go, as it will basically have the same hardware as the primary IT infrastructure, just not delivering the workload, just not serving its purpose most of the time. And again, virtualization is great here because we can manage our VMs more efficiently. So that's why you might size it lower than the primary IT infrastructure and just provide enough resources in terms of CPU and RAM to run your VMs. Maybe not that fast as it would be on the primary infrastructure, but still just enough to keep your business running. Now, talking about sizing, storage plays the specific role here when we are talking about the asynchronous replication on the VM level. Now, we need to pay special attention to storage because with asynchronous replication, you can choose how many recovery points you can save. Based on this, you might want to provide, in fact, more storage comparing to your primary storage system. This is in order not to end up in a situation where you have a large chain of recovery points, or basically snapshots, that you would not be able to maintain and as a result, crawl back in time. So usually providing a bit more storage for the DR can be considered as a good practice. Now, how often should we replicate, basically frequency? So it is of course understandable that we have determined our recovery point objectives, which is great, but we need to take into account several very important things. Asynchronous replication tools offer a wide range of settings. You can set the intervals between the asynchronous replication in minutes or hours. But what is important to understand is if your network and the speed of storage on the DR side is actually capable to write the amount of data. Of course, this depends on how many VMs you have, and most importantly, how many writes or changes they are doing during that time. What I mean is that you can set an RPO, for example, of 5 minutes, but you have a lot of VMs writing many changes, most likely the network bandwidth, unless you have really good bandwidth between the DR side, which is not always the case, or more often is not the case than it is, simply won't be enough to write all the changes. And this will just result either in the not meeting the schedule, postponing subsequent replication further, or just getting an error for the subsequent replication job. And the final thing, when we are talking DR in virtualized environments, are the tools. Now, this functionality is basically already embedded on a hypervisor level, like Hyper-V or vSphere, or this can be part of the third-party backup tools. Now, the variety of backup software, backup solutions also provide asynchronous replication for VMs as an option. But let's start from the most common hypervisors and from the tools that they have already prepared. So let's start with the Hyper-V. Now, Hyper-V has the feature called the Hyper-V Replica. It comes at no additional cost with Microsoft Hyper-V. It is, of course, asynchronous and is based on the intervals you set. So again, we keep in mind that there can be zero data loss guaranteed. Now, if we're talking about the source and target hosts, what is supported and what is not, that's pretty much anything. So Hyper-V hosts can be standalone, they can be cluster, or this can be a mixture of both. Now, when you replicate a VM for the first time, and I have to say that this is pretty much how any asynchronous replication would work, either Hyper-V or vSphere or Veeam. So when you perform the first replication, basically the initial replication, all VM data is copied from the source host to the target host. The next time the VM is replicated, only changed VHDX or VHD data is copied. You can also use a pre-existing restored VM. For example, if you have restored an early backup of the virtual machine on the replica server as the initial copy. That basically is to save the bandwidth and to reduce the time required for the initial replication. Or you can copy basically the initial VM disk to external media and then physically deliver that media to the replica site and then start the replication. Now, if we are talking about the failover and failback, because these are pretty much the most important things we would need with the replication, the ability to fail over and the ability to fail back. Now, Hyper-V in this regards provides a variety of options. So it can perform the test failover. That would be once you want to test the DR strategy that your replica actually works. So you test this on your replica virtual machine and basically check the sanity of the virtualized workload without interrupting your production workload or ongoing replication. Basically, it creates a new VM on the replica side. You can test, see basically if it works, if the replication works properly, and then remove. Then you have the planned failover. So planned failovers in Hyper-V are used to, well, either prepare for an upcoming disaster, but most likely for the maintenance or when you need to migrate the data center, migrate the IT infrastructure. During the planned failover, the primary VM needs to be shut down, otherwise it will just throw an error. And then it synchronizes the latest changes, and the replica VM can be started on the secondary host. Basically, this means that in this case of a planned failover, there will be no data loss when you use this scenario. Now, the other type is the unplanned failover. Well, I guess we all understand what it's referring to. It's the operation that you would initiate on the replica VM, so on the partner, on the remote side, when the primary infrastructure or virtual machine, can be just a VM, not necessarily the entire site, is offline or inaccessible for some reason, be it a disaster or VM is corrupted for any reason. If you have turned on the recovery history, basically you have set to keep multiple recovery points, you can also perform the unplanned failover to that previous point in time you select. As to failback, there is no automated failback. So once you have done the failover, you can do the reverse replication straight away. But what this means is basically that the replica VM that was on the DR side will become the primary. So you will need to reverse the replication order and then again perform the failover for your primary site VM to become primary again. Now, as to frequency, Hyper-V Replica offers a range of 30 seconds, 5 minutes, or 15 minutes. So that will be your recovery point objective. And next on the list is vSphere Replication. vSphere Replication is a hypervisor-based asynchronous replication for vSphere environments. As to source and target hosts, these can be standalone ESXi hosts, these can be cluster or also a mixture of both. But vCenter is mandatory. What this means is that you can have, for example, a standalone ESXi host as a source in your primary data center and standalone ESXi host as a target. But both these should be under vCenter license. So in any case you configure vSphere replication, vCenter is always mandatory. Now, as to vSphere replication, it's very similar to what we have described previously in Hyper-V. So it performs an initial full synchronization of the source virtual machine and its replica copy. Then vSphere replication agent sends change blocks in the virtual machine disks from the source side to the target side. Now, you can also use replication seeds to reduce the network traffic that would be generated during the initial full synchronization. A seed copy is basically a virtual machine disk file that you can place at the target location. As to how to do this, well, it's pretty much up to you because the process is manual, so you can use offline copying, FTP, an ISO image, or a virtual machine clone. Also, you can optionally enable data compression in vSphere replication to further reduce network bandwidth consumption. As to failover options, again, very similar to what Hyper-V has, albeit with different naming. So in vSphere, you actually perform a recovery of a virtual machine by using either synchronize recent changes option or use latest available data option. Synchronize recent changes option is similar to planned failover in Hyper-V, and it requires your primary VM to be stopped. So this is something you would use when planning to perform maintenance, for example, in your primary site. And correspondingly, use latest available data means that you can perform this operation during the actual disaster, and it also allows selecting to which point in time to travel in your virtual machine if you have configured vSphere replication to keep multiple recovery points. Now, there is no failback in vSphere replication, so if you have performed a failover, you would need to configure replication in a reverse order to your primary site and then do failover once again. Now, as to frequency, that's a range from 5 minutes and up to 24 hours, and that's pretty much flexible. Now, also, what is worth mentioning is that vSphere replication is what we would probably call a basic DR functionality, while there also is vSphere Site Recovery Manager. Now, vSphere Site Recovery Manager already gives more capabilities and is more feature-rich. So, for example, it allows setting policy-based management on a storage level. It allows creating recovery plans for your VMs, for example, to group them and specify the order in which the VMs should be failover. Of course, it also allows for more automation when it comes to failover and failback. And what is great, also allows for disaster recovery testing. And finally, we have Veeam Backup and Replication. Now, Veeam is just an example which we use because a lot of backup software vendors provide not just backup functionality, but also replication, or in other words, disaster recovery features. Now, for Veeam Backup and Replication, it supports both Hyper-V and ESXi. So if we are talking about source and target host, this can be standalone Hyper-V hosts, Hyper-V clusters, or a mix of both. And same goes for ESXi. So standalone ESXi hosts, clusters, or a combination. Now, as to Veeam replication operation, again, this is very similar concept, so it's all based on the asynchronous replication, obviously. And during the first replication cycle, Veeam basically copies the data of the original Veeam, the one running on the source host, and creates its full replica on the target host. Now, unlike backup files, replica virtual disks are stored decompressed in their native format. All subsequent replication cycles are incremental. And to replicate VMs, Veeam B&R uses VMware vSphere or Microsoft VSS snapshot capabilities. Now, also to basically make replication over slow connections easier, Veeam can optimize traffic transmission, so it can filter out unnecessary data blocks such as duplicate data blocks or zero data blocks, and compress replica traffic. Now, as to the failover, so there are, again, similar options in Veeam as we have previously discussed in Hyper-V and ESXi, but it is a more, I would say, step-by-step process in terms it has first steps and finalization steps. Now, first steps would include failover, during which Veeam recovers the Veeam replica to the required restore point and shifts all I/O processes from the original VM to its replica. Now, you can fail over to replicas not only when a disaster strikes, but also to test replicas for recoverability. And planned failover is basically the smooth and manual switching from a primary VM to its replica with minimum interruption in operation. And again, planned failover speaks for itself. So this is something you would use when preparing for primary data center for your production infrastructure maintenance. Failover, which we have spoken previously, is again what you would use in case a disaster happens. Now, the other option is to configure failover plans. So a failover plan is basically a sort of automation because it allows grouping virtual machines and specifying the order in which VM must be processed and failed over. Now, all these first step options require finalization, and finalization can be failover undo, permanent failover, or failback. So yeah, finally we have failback, and basically the failback allows you to switching back to the production VM from a VM replica and shift I/O processes from disaster recovery side to the production side. Now, failover undo is basically to neglect to undo all the changes in the replica VM and go back to the primary virtual machine. And permanent failover is when you want to continue with your replica VM and basically make it already as your primary virtual machine. Now, as to the frequency, there is actually a wide range of options. So it can start from continuous replication and up to periodical replication starting from minutes or hours, or for required schedule. Now, also Veeam has Veeam Disaster Recovery Orchestrator. Now, it extends the replication functionality and also gives us some new features. As an example, you can run automated disaster recovery tests, generate documentation on your DR plan to see whether it meets your recovery point and recovery time objectives or not, and if not, what can be improved, and also simplifies and automates basically management of failover and failback processes, and also some other features. So this is basically it for our today's webinar. So if you have any questions, please let me know about them in the question section, and I will try to answer them. Okay, and one question I see, is it possible to automate failover? While I would say that yes, it is certainly possible to automate failover with some portion of scripting, for example, with PowerShell, and using the Veeam or Hyper-V or vSphere functionality, it is possible, but it might be not the best idea. Why there is no automatic failover as such, for example, as when the primary VM goes off, and then you would just automatically, by default, switch to the replica VM, is because the software in no way can tell whether there was a reason why you have turned off the primary VM. So you simply just might turn it off for some specific maintenance of that VM or other when you do not really need that workload. But in that case, with fully automated failover, the software will simply run the partner straight away and switch the workload. And in some cases, you would not want that. So possible, desirable, very depends, and I would say more no than yes. Can StarWind vSAN replicate VMs asynchronously? Speaking shortly, no, StarWind vSAN cannot replicate VMs asynchronously. Speaking longer, StarWind vSAN performs replication, which is active on the storage level. We might be adding the storage level asynchronous functionality in the future. But again, extending the reply, if you have different sites, you can also configure the stretched cluster. Of course, networking requirements will be different. Certainly, higher bandwidth will be required. But you can, again, set the stretched cluster between the two different sites and have active replication, which StarWind does on the storage level. So ultimately, if one of the side goes down, the other side will be able to fail over the virtual machines and keep them running. That will be done, of course, automatically. Is Hyper-V support SQL data replication properly, or are there any chains to lose the data? Now, I wouldn't speak if there is any chance to lose the data. Well, certainly with asynchronous replication, if you're not doing the planned failover, there will be the data loss. It is possible to use Hyper-V Replica with the SQL, but I would also note that SQL also has its own replication capabilities that you can make use of, and that would most likely exceed those of the Hyper-V Replica. Do servers need to be in domain for Hyper-V Replica? No, there actually is no dependency of Hyper-V Replica on the Active Directory, and the target and host servers do not necessarily need to be joined into the domain. Which vSphere license includes VMSRM? VSRM. So that would be ideal question for VMware directly. But as far as I remember, I'm not providing the 100% guarantee for this answer. As far as I remember, VMware Site Recovery Manager is licensed separately, and it's per protected virtual machine, and it goes in packs. There is also the standard and enterprise version. Standard, if I'm not mistaken, is up to 75 virtual machines per site, and the enterprise, if I'm not mistaken, is unlimited. Again, as far as I can tell, is the separate licensing per VM. And yeah, as far as I remember, it's sold per packs for VMs, 25 if I'm not mistaken. If we have SQL Server, we have to use SQL replication. Now it depends on Hyper-V replication. Pretty much so. You can use SQL Server with Hyper-V. There will be a data loss when you recover, depending on the RPO. Again, 30 seconds, 5 minutes, or more. Hyper-V Replica, however, does not support any SQL native high availability features, such as availability groups or database mirroring. So again, depends what exactly you would need, but my advice would be to go for the SQL Server replication features. Okay, so I think we'll be finalizing for today. Huge thanks actually to everyone joining this webinar. Thank you for your attention, and I hope to see you on our upcoming webinars. Wish everyone all the best, stay safe, and goodbye.